second. I want to see who's talking. Okay, it could be my voice who did the interference. Okay, let me go into Carl. Carl, I'm sorry to display all the grades, but there's nothing to hide. This is not really important. It's basically lab 1. So Carl, let me see if you can see the commands. They are usually in a different color. If you go inside, you see this? Yes, Carl, are you with me? By the way, I need to remove my earphones so I can record your voices as well. Yes, Carl. So do you see the blue command? Yes, you should be able to see this on your Blackboard. And if I go into answers, I believe you can see some commands here as well. You see? Do you see those commands?
I checked Blackboard through my phone, so only I could see the grade. I didn't open it on my laptop.
Okay, so it's very important to check your grades. I have very important comments to consider. So I'm sure you did not consider those in lab 2, and it's okay. Now, while you do lab 3, check my comments. I have some comments related to lab 1, if not, nobody else would want to say something. I noticed that a lot of you are actually showing many files. Please do not submit many files. You're supposed to submit only one lab report. If you want to add something, Carl and Rima and Leah, is that it? Anybody else joined us? Let me see the list of participants. We're only 4 now today. All right, so make sure you submit only one file. For example, for this Excel sheet, you can simply crop your work, take a screenshot, and insert in your document. And please, your document show, like I'm writing in here, it's a report, it's not a homework. Like you have to show maybe a cover page, the date, your name, the title. It's important to say the title of the lab, okay? Then please write the questions and the answers. Okay, by the way, the way the lab report looks like will not affect your grade. You can see Carl showed me a very ugly lab report, but I had to correct the content. So your grade will not show any problem in the presentation. I just want you to work on your presentation, Carl and everyone else. By the way, I had a very big talk with Michel this morning about his presentation because we had a small clash initially, like a communication issue. So the way your lab report is presented is very important, and I'm gonna push you to present the best lab report ever, although this will not show in the grade, okay? But by the end of October, when we reach close to the midterm, I want you to be ready to submit a reasonable midterm. I have one comment that happened with my other class. A lot of students were actually submitting their work as document, but some equations and some graphs were altered. So the best way for you not to make sure that your lab report will not vary after submission, you can convert your document to PDF, then submit. It's better, it's so much better. Okay, so if you need help on how to submit lab report, please let me know. I can send you tutorials and I can meet with you. You can share your screen to show me your problems. Okay, any other comments concerning lab 1? No comments? How about lab 2? So I can see that many of you submitted lab 2. Do you have any questions? By the way, if you believe you did a mistake or you want to modify something, you can at any moment submit again. Don't worry. Just let me know through a note somewhere for me to check your work. Okay, you can write a note for me. You know this? Yeah, you can submit and write a paragraph, a note, something to tell me, please ignore attempt number 1, take into consideration attempt number 2. I modified the graph. Let me know what you modified. You will make my life so much easier. Okay, no questions concerning lab 2? All right, shall we move to lab 3? Please answer me back so I know you're listening to me or you can hear me. All right, so lab 3, I prepared a PowerPoint presentation that is actually empty. I want us to fill it in together. And every time you need to see something, unmute yourself. It's much better than using the chat box. All right, for me to start discussing what projectile motion is, I assume you don't know it from the course. I assume you basically know it from high school, maybe not. So I'm gonna start from scratch. It could be a good review for you. So, and let me move these a little bit to the side so I can use all the features. So I need somebody to remind me what is UARM, like Uniform Rectilinear Motion. How do you define it? Yes, any thoughts? So URM, what is it? You guys, I need your help. So I'm waiting for Leah, Carl, and Rima to respond. Assuming nobody else joined us, yes. And
What's the question?
Yeah, so the question is uniform rectilinear motion, how do you define it?
Constant V.
Say it again.
Constant velocity.
Time times velocity. What's times velocity?
No, not time, constant velocity.
Oh yeah, I'm sorry. So I'm gonna write V is equal to a constant. What else? Yeah. Girls, can you help Carl? Rima is trying to speak. Okay, Rima cannot hear me. Rima, try. She will not be able to hear me. So, by the way, I'm ready to really go slow to help you out. Leave the session and come back. I don't know what to say. I cannot hear you. Yes, Leah left as well. So, Carl, you help me. Can you please help me out with the acceleration? What do you say about the acceleration?
Equal to 0.
Yes, this is great to write down. Anything to say about the x? I mean, in my position.
It's varying as a function of time.
It's varying as a function of time. Is it a linear variation or a curved variation? It is a linear variation. It's very important because since you have a constant speed, yeah. So I'm gonna write it as v times t plus my initial position. If you want to say it, I'm gonna call it x0. All right, so
can you hear me now?
Yes, I can hear you. It's great to have you back. So far, for uniform rectilinear motion, this is all I can say, that the acceleration is 0, v8 is constant, and x acts like vt plus x0. All right? Maybe I can show some graphs. It would be a good review for us. So maybe I can show that the vt graph. So this is vt. Do you know how the vt graph looks like? Horizontal line or straight line or curve?
Straight line.
It is a horizontal line because we just said v is constant. And if I need to discuss the xt graph, how does it look like?
A straight line.
Yeah, it can start from any point on the x-axis. It can be negative, and maybe you can have a positive slope, or you can have a positive y-intercept with a negative slope, or positive y-intercept with a positive slope, depending on the values, as long as it is linear, okay? So this has to have 0 slope. So I'm gonna write that the slope is equal to 0. This is very important. And other than that, you can do anything you want, all right? So this is uniform rectilinear motion as a review. Now, if I need to do uniformly accelerated rectilinear motion, how do you proceed? So I want you to tell me a bit about the acceleration. What do you know about this? Can I say the acceleration is 0 or constant or linear in time? You guys,
Constant.
Yes, it is constant, and this is very important. Any thoughts about V?
Vx plus Vxt plus V0.
Actually, I cannot say V is equal to V times time, because look at the units. You cannot have meter per second to be meters per second times time. It's basically V0 plus A times T. Okay? Any thoughts about X?
half 80 squared
Yes, you got
plus
it.
V0.
Okay, 80 squared plus V0 t. V0t plus, if you want x0, by the way, x0 is usually 0, so sometimes you don't see it in the equation. Let me fix this to superscript. All right, do you know other equations you can use? So these are basically the definitions, like other equations you can use. You know the equation of v squared, the equation of x, that some other equations? I would love to write them down to you. Like this one is v0 squared. So let me show you the square, and the plus 2ax, 2a delta x actually. Have you ever saw this equation? And this one states,
yes, and physics course.
Yeah, v0 plus v, all of it over 2, and then you multiply by time. All right, this is very beneficial in case you are not given the acceleration, and this is very beneficial in case you are not given the time. I don't really actually need those. I only need the v equation and the x equation. So maybe undo, maybe keep them in yellow. Let me see if I can change them to yellow so we can keep them. All right, and for this one, I only need the x equation and the v equation, which is this. Let me, okay. Fine, so let's discuss a little bit the graphs in here. Maybe I can do it for you by stating the recording, yeah. So, draw, yeah. How do you believe the VT graph will look like? If you don't know, look at the mathematical equation of it. Is it constant? Is it linear in t, or is it t squared?
Linear.
Linear in t, meaning positive or negative slope. Now, what about the x? Is it constant? Is it linear in t?
It's a curve.
It is a curve. It can be any curve, by the way. Okay, let me write x as such. So it could be this, for example. Okay, so anything would work. All right, now projectile motion, you need to understand that it's made of two motions. Like when you throw something up, you see the shadow on the floor and the shadow on the wall. Can you tell me, oops, I'm sorry for this. Can you still see my screen?
Yes.
Okay, I'm gonna show two boxes to separate the X and the Y motion. Okay, I'm gonna call this the X motion, and this one I'm gonna call it the Y motion. Okay, and maybe make this a little bit bigger so you can see it. We've been using font 28. And I want please the girls to talk to me as well. So for the X motion or the shadow on the floor, can you guess if it's constant acceleration or constant speed? So again, you're throwing something and you're looking at the shadow on the floor. Do you think it's an accelerated motion or not? Any input? Hello, Fadi, thank you for joining us. So Fadi, in your absence, we were actually doing discussing what is uniform rectilinear motion, the equations and the graphs. Then we did UARM, the equations and the graph. Like we're building up the PowerPoint together. Now we're discussing that projectile motion is done of two different motion, independent motion. All right, Fadi, you're talking. I'm not being able to hear you.
Yeah, doctor. Hello, how are you?
I'm good. It's great to catch you. So can you please help me, Fadi, or anyone else? Projectile motion, if I'm throwing something, like I'm playing basketball, you have the shadow of the ball on the floor and the shadow on the wall. Can you please tell me the shadow on the floor, the X shadow, is it moving at a constant speed or is it speeding up? I need an answer. Carl?
Constant speed.
Constant speed, thank you so much. So I'm gonna write it down in here. Yes, so this is A is equal to 0, no acceleration on the floor, which means V is equal to constant. I'm gonna call it V0 along the x-axis. I suppose the x is gonna be half 80 squared, but no, actually it's gonna be V0 plus 80. How do I know all this? I just took them from this equation. So by the simple fact that Carl just said constant velocity, I can take all this. Okay, so what I just wrote, I wrote that the acceleration is 0, v is constant, and I called it v initial. Yes.
X is v0 t plus x0.
Yes,
it's not
thank you.
plus
Thank you so much. It shows that you are really following with me. Thank you so much. All right. Anything else you don't agree with? Okay, now for the Y motion or the motion on the wall, what do you know? You throw the basketball. You see the motion on the wall. The shadow would go up, will stop for a second, and then will come back down. How do you describe the motion? Is it constant speed or a variable speed? Yes?
Variable speed is constant acceleration.
What is the acceleration? Do you know what it is?
9.8.
Let me say it's negative because I want to state that it's downward, okay? So for me, it's gonna be negative 9.8 meter per second squared, okay? And the negative mean it's downward, okay? If you want to take the downward motion to be positive, just remove the negative. Carl, so is it a URM or a UARM motion?
UARM.
Okay, I'm gonna copy all these equations, or maybe only the yellow ones. Okay, I want to copy them, why not? So let me go up, okay, and write them in here, but I will do some tiny modifications. Okay, you can help me with the modifications. I'm gonna call V, okay, let me call this one Vx, and I'm gonna call this Vy, just for me not to be confused, and this is V0y. The acceleration, can I simply write it down as negative g to make my life prettier? Maybe like that. And here I'm gonna write negative g instead. So negative g means the acceleration. And I'm gonna write negative in here, and instead of a, I'm gonna write g, and this is would be called Vox. And this, no, Voy, and I'm gonna call this my y-axis, and this my y-axis. So what I'm trying to do here, I'm trying to show you that the equations you know from URM and from UARM are basically the exact same thing used in projectile motion. It's only that I can split the motion into X motion and Y motion without worrying of anything. And how about I remove acceleration because I don't care about it, I already wrote it in here. Okay? All right, now I'm struggling with one item, one very important item. Like A, I know what it is. Vx, I understand. X, I understand. Y, I understand. But V0x and V0y is something that I do not understand a lot because usually they are not given to me. Like I need to find them out. Let me change them into this color. So I'm worried about V0x and V0y. Let me show this as capital V. So in this next section, I want us please to try to figure out what V is. So I'm gonna show you what exactly is happening. Like here, this is your wall, your y-axis. Rima, is it okay?
Yes, I can. I think it's clear.
Okay, great. Leia, you're good? Okay, this is your X.
Doctor,
Yes.
are you speaking to me? Because I can't hear.
Yeah, I know. I'm so sorry for that. Please watch the recorded session again. I don't know what's happening with you. Yes, I can hear you, and I was checking if you understand.
Okay, okay.
Fadi, in your absence, we've been talking about Lab 1 and Lab 2. Please watch the first few minutes of the recorded session so you can see what you missed. Okay? So now I'm gonna show you the initial speed. This is the initial speed. This is V0. All right, and you can see an angle. Maybe show the angle in red. This is the angle, the shooting angle. And a projectile motion is gonna happen like this. Now my question is, how do I calculate the X component of V initial and the Y component of V initial? Anybody has an idea how to proceed? Maybe Fadi can help me out. Fadi?
Yeah, doctor.
Yes, so you see the vector V0.
Yeah.
Do you see the shadow on the floor that I'm gonna call the X component?
Yes.
Do you see the shadow on the wall?
Yep.
Okay, so this is V0Y. 1 second, undo. This is V0Y. And this is V0X. Can you please calculate V0Y and V0X knowing the angle and V0 being the initial speed? Okay, if you cannot do it, I can help you by stating the SOHCAHTOA. Do you know the SOHCAHTOA? Fadi, stay with me. Fadi, are you with me?
Yeah, doctor. Sorry, I just switched rooms because it was very noisy.
All right, I really appreciate that. So I want you to focus at V0X. Is it adjacent to the angle or opposite to it?
Adjacent.
Adjacent to the angle. So I'm gonna use sine or cosine?
Sine. No. Cosine, sorry.
Okay, so I'm gonna say cosine of the angle is equal to adjacent, which is V0x, over the hypotenuse, which is V0.
Yes.
Okay, can you compute V0x for me now? So V0x is gonna be equal to, can I say it's V0 times cosine of the angle?
Yeah.
Okay, times cosine of the angle. Okay, cool. Now, how would you find the y component or the V0y? Is it opposite to the angle or adjacent?
Opposite.
Okay, so do I use sine or cosine?
Sine.
I'm gonna say V0y is directly V0 times the sine of the angle. And I'm gonna remove this multiplication because it will look like X. Okay, this looks so much nicer like this. So what you will be given, you will never be given V0 X and V0 Y. You will always be given V0 only, and your job is to break down the V0 into two components, this one and this one. Maybe I can show you those in yellow so we can keep them for later on. Okay, this is the yellow I'm gonna use. So far what we did uniform rectilinear motion alone, then uniformly accelerated, then projectile motion is made of two types of motions. We compared them, we discussed what is the initial speed. Now I need to discuss what the range is, because our job in this experiment is to do what? To measure the range, but you need to know what is the equation of the range. Okay, let me start by explaining exactly what the range is on the graph, and you can help me mix down the equations. Okay, maybe Rima can help you with it. So this is the x-axis, and this is the y-axis. Projectile motion is happening like this. So this is the range. The range by definition is the distance between the launching point and the landing point. Very easy. How do you find the range if I ask you to use those equations? Maybe I can take a screenshot of those equations and insert in my manual in here. Yeah, so I need somebody please to help me mix those equations. I'm fetching the screenshot and let me make it small. Okay, this is the screenshot. So please use my equations to be able to find the range. How do you proceed? The range, is it an X or a Y?
We choose X minus X0 equals V0t.
Which one?
X equals
Okay.
V0 X0.
Okay, so you're telling me to start with this one. I'm just gonna take it from here so I can copy paste it. So copy paste. Let me insert a box to write in. So you're saying to start with this one, right? Then what? I need the time. Can you try to come up with an idea on how to replace time? By the way, I can replace this by V0x, right? Isn't it? Okay, so I'd rather take it from here. It's, by the way, this should be V0x to make your life easier. I just fixed it, okay. Yes, so the range, V0x, x time, x0. Can I say that x0 is 0? So this one is equal to 0 because it starts from the origin. And I can replace V0 by V0, what was it, cosine? Yes. So let me replace it by V0 cosine the angle, cosine theta. So this I'm done with, this I'm done with. I still have the time. How do you find the time? And maybe probably call this R. This is my range R. So we just found the R. V0 is given, theta is given. This is equal to 0. I still need the time and I need help. How do you find the time? Any idea?
It's Vy minus V0y over minus GT.
Okay, so you want to take this
minus
to
G.
find the time. Awesome. Who was talking? Was you? Is that Fadi?
No, it's me, Carl.
Carl, yeah, Carl, you are a genius. Okay, so I'm gonna help you by stating that Vy is equal to V0y. So I'm gonna take the time from here, minus GT. G is known, so I can keep it, no worries. Time is what I need. Can you guess, but I don't know nothing about the final speed. I can tell the initial speed, but the final speed at this point, I know nothing about it. So you're very close, but this equation is not gonna help me. I have two unknowns. Can you think of something else?
We use the bigger equation, y equals minus half.
Okay,
GT
this one.
squared.
We want to use this one. G is given, V0y is given. What is y0? Do you know?
0.
0, awesome. What is y at this position?
Also 0.
Also 0. So I have everything I want. I can easily find time. So I find time from this one and I replace in the equation to find the equation of the range. Now let me go and find your lab report. I can show you. So it's gonna be Physics 111, my lab reports. We're doing projectile motion. I want you to see the equation of the range. Okay, maybe we can take a screenshot and put it in our, yeah, just a second. What's up with this one? Why does it look like this? Okay. All right. So they're actually trying to explain those equations, and this is the equation of the range. By the way, they explain the height and the range, but in this lab, you will only need the range if I'm not wrong. So you will take this equation only. So again, how did I find this equation? By simply doing the work we just did. So just find the time and replace it in here. I will give you some time to think about it, and you will end up, maybe I can insert the picture. And on this slide, do you think the slide can fit in more pictures? Maybe. Make it small. Okay, it's small enough, I suppose. So this is the range I just need to find. So if you really look into it, theta is something you can measure, and V0 is something that you can measure, or is the result of the projectile motion. Okay, now let me discuss the experiment. We're done with the theory. How does the experiment look like? You will be given, let me show you a sketch, and then I will show you the video, and then you can leave. So basically you have a desk, like a desk on the floor. Maybe move it a bit. So it's like a tiny table on the floor with legs, and we need to make sure that this table is horizontal. And I have a big machine that I'm gonna call the gun. Okay, it has on it something like a gun with a protractor. Okay, protractor like this, like you can tell the angle. Okay, and you put the ball inside and you shoot. Like for example, if you do this, the shooting is 0. And then you can turn your gun with a different angle and the shooting is gonna go at a certain angle. All right, you can modify the initial speed. I can show you how. There's a spring and you will be actually sending your ball with a certain initial speed, and you have a timer in here that would give you the initial speed. So initial speed is your variable, you can measure it. Angle is your variable, you can measure it. What you measure eventually is R. And R, you have to be careful with R. R has to be measured from the final landing point to the initial launching point. So all this. Now, how do you see the landing point? You would be given like carbon paper. I don't know if you know what it is. And this carbon paper will mark a dot on the table so you can locate the point and use a ruler to do the work. Okay? Let me show you the video. I'm gonna run the video slowly. Actually, I'm gonna pause at many intervals, but you can watch it later alone in full, okay? So, I don't know if the girls can hear me. So projectile motion, it's a one video, it's 6 minutes only. You can see the desk. You can see the ruler I will be using. It's important to focus on the number of the smallest subdivision to be able to tell the error, okay? I'm gonna show you the lab report in a moment so you can see how to work. This is the gun. You can see it is already at 0 angle. You can see the timer to see the speed, and this is the angle. So how about you see how things would work? This experiment is projectile motion. This is your system. By the way, I'm very sorry for the echoes. I was not using the lab. I was using a different classroom because I was not allowed to use the lab on that day. So I'm sorry for the sound. The mass of which is not known, and you don't actually need it. You have the gun. We can call it a launching device or a gun. The angle of the shooting angle can be varied. I will explain later on in details how to vary the angle of the shooting. You can also measure the initial speed of the ball in meter per second with 2 decimals, for example, 7.21 meter per second. You have the track. This is the landing track. It's basically like a bench on which you place A4 paper, and on top of which you place carbon paper. And every time this ball will hit the carbon paper, it will create a mark, a dark blue mark on the white paper. So you would know the landing point. Knowing the launching point and the landing point, you can measure the range. So in this experiment, your job is to measure the initial angle, the range, the initial speed. You will vary angle and speed, and you will see how all this will be affecting your range. So this is the gun that I will be using. Let me explain how to modify the different parameters. First of all, you're supposed to change the angle. The angle of the shooting right now is 0. So if you all right, so it's very important to state here what are the variables. Okay, so do you understand from this description what were the variables? So what are the variables? And what do we measure? What do we measure? Can you please tell me? Anyone other than Carl?
Can you please repeat?
Yes, so my question is for you. From this experiment, do you understand what are the variables and what do we measure? What do we vary?
Initial point?
Say it again.
Is it the initial point?
Yes, the initial point is the variable. What do you understand by initial point? Like, what do you vary from it? Its position, speed, angle, I don't know. What do you change at the initial point?
The range?
No, the range is what we measure. That's the final thing. So the range is the final measurement. But what do we vary for every trial? We vary the initial speed and we vary the angle. Okay, initial speed. The angle is easily, you can easily vary it. You can see in here how I was varying the angle. You see how I vary the angle. And you can read the smallest subdivision easily. This is very important. Okay, so I can change the angle. How do I vary the speed? Let me show you. Okay, this is how I vary the speed. will give you a certain initial push, this will give you a stronger initial push, and this will give you the strongest initial push. Okay, so you see the 3 initial push, like you have 3 different speeds. For each speed, you have many angles. Now let me go back to the lab report to show you what you're supposed. Did I minimize the lab report? It's here, projectile motion. Okay, so let me show you the table of measurements. You will do velocity 1, velocity 2, and velocity 3. You will measure for each angle what the range will be. So this is a variable, and this is a variable, and this is your final measurement. And then you need to answer those questions. To plot, to deduce, to sketch, and that's it. You only have 3 questions. Nothing else will be asked from you. Okay? So this experiment is not very long. The experimental procedure is long, not the lab report. Like when I do the experiment in the lab myself, it takes me like an hour or like an hour and a half to finish. But eventually the lab report is not very difficult. So do you think you can do this? I will definitely gonna stop here. I think this document can stay with us. You will have the chance to watch the video from the beginning until the end and take notes if needed. And you will be given the lab report with measurements, like for the range, for you to be able to answer the question. Okay? And please, if they ever ask you to plot, you do it on Excel or on a graph paper, and you insert your document in this empty space. And whenever they ask you to sketch, you can easily sketch on a paper and take a picture, insert in your document in here, and eventually you can click File, Save As, and you can easily do PDF. And once you have it as PDF, you can upload it. Fadi, I want to show you something since you are with us. When you go to Lab 2, for example, there's a section called Submit Here. If you click on it and click Submit Here again, you can write something if you want, and you can browse your computer to be able to upload the file you need. Okay? Fadi, are you?
Yeah, doctor, I know how to do it, but for some reason there was something wrong in my laptop. I don't know what the issue is.
Okay.
I saved everything, and when I went to submit it, I couldn't find it on any of. I saved them on my desktop, and I couldn't find it there.
Okay. Do you have access to any other computer?
Yeah.
I want you to try on some other computer. Just email it to yourself or have it on a flash disk. I want you to try because it's very important to have everything graded on Blackboard for many reasons, because eventually I need your average from Blackboard. Okay? I'm sorry for the hassle, but you will get used to it, and this is what we will be doing in midterms and exams later on. So there's no, like, you cannot escape it. So anyway, get used to it.
Okay, doctor.
All right. And yes, Carl.
How can we submit the homework in one file?
All right, so usually, for example, here, this is my lab report. I can click in this one and insert any picture I want, okay? Usually I take, for example, let me show you what I have on my desktop. This is a screenshot. Insert. Now I have it inside my document.
So I insert the Excel graph because I'm plotting my graph always.
Okay, do you know
Excel.
how to use the feature screenshot? Because not everybody knows.
Yes, I know.
Okay, so screenshot your Excel and crop it well, insert in your document.
Okay.
You can also, I think you can do copy paste from Excel. Okay? I know, Carl, this is new. I know this is new, but try. It's fun. And once you learn how to do it, it's going to be very easy. It's not like I knew how to do it many years ago. Like I did like you, I tried. But eventually, Carl, it's important for you to present one document. You will have to write lab reports later on at LAU, and you need to present one document, and usually it has to be PDF. Nobody would accept many documents. Okay?
Okay, doctor.
And please do it on PDF. It's not obligatory, but it's so much better. I think the file is gonna be less in size as well, if I'm not wrong. Okay? If you have any technical difficulty, please let me know. I can try to send you a tutorial and I can help you, and don't get overwhelmed, you will get used to it, okay? All right, anything else?
Okay, thank you.
All right, if you have no more questions, you are dismissed.